The interstellar void is deep and black as eternity, but scattered through it are worlds that burn with their own quiet fire. Not every world needs a sun to shine. In the vast reaches between the stars, a strange kind of world drifts alone, unlit, unanchored, and untethered to any sun. These are the rogue planets, wanderers of the void, cast adrift through cosmic misfortune, or possibly born that way, in the cold interstellar wilderness. Today we're returning to a topic we explored years ago, but with sharper eyes and broader horizons. Back then, we considered the rogue planet mostly as a curiosity, a scientific puzzle or a doomsday hypothetical. But a lot has changed since then. Not only have we learned more about how common these worlds might be, but we've also deepened our understanding of how life might survive on them, and how we might one day call them home. This is Outward Bound, our series on how humanity might colonize the toughest, weirdest, and most extreme places in the cosmos, and rogue planets might just take the crown. No light, no sunrises, no seasons, just a frozen sky and whatever warmth you can bring with you, or dig down to find. In the interstellar night, warmth is a treasure and pressure is life. Survival doesn't begin with oxygen or sunlight, it starts with shelter from the void and enough energy to keep the blood moving and the machines humming. But even in the deepest dark, possibilities persist. Some of these worlds may harbor hidden oceans warmed by internal fires, or thick atmospheres of hydrogen and helium insulating seas of exotic liquids. Others may be massive enough to retain their moons, even build entire ecosystems beneath layers of ice or gas, and with the right tools, fusion power, megastructures, a little audacity, we might not just survive on these lonely planets, we might thrive. So, what exactly is a rogue planet? How many are out there, and what would it really take to build a civilization on one? Let's begin by charting the territory. What are rogue planets? Rogue planets, also called interstellar planets or nomads, are planetary mass bodies that drift alone through space, unbound by the gravity of any star. They don't orbit anything. Instead, they wander the galactic void, tugged along by the gravitational tides of the Milky Way and the occasional passing star or molecular cloud. Unlike the icy rubble of the Kuiper Belt or Oort cloud, rogue planets are fully fledged worlds, ranging from frozen rocky dwarfs to gas giants and even brown dwarfs. These lonely wanderers may seem like rare cosmic accidents, but modern surveys and simulations suggest they could be shockingly abundant. While early estimates hinted at 1 or 2 rogue planets per 100 stars, newer data from microlensing surveys, such as those conducted by Ogle and MOA, suggest the real number could be far higher, maybe even 100 or 200 per star. That means there could be tens of billions to hundreds of trillions of rogue planets drifting through the Milky Way, vastly outnumbering the stars themselves. Much would also depend on how we counted them, in terms of minimum size threshold. By and large, we find that the frequency of celestial bodies has an inverse relation to size. Something several times larger is several times less frequent, and smaller things several times more common. So far from being outliers, they might be the hidden majority of planets in our galaxy, dark, silent, and waiting to be found. But how does a planet become a rogue? Some are likely born that way. In the early days of star and planet formation, chunks of gas and dust collapse into massive bodies before a star fully ignites. In dense stellar nurseries, some of these clumps never end up in orbit around a star at all. Instead, they form planet-sized objects that never knew a sunrise, drifting away even before the local stars have settled down. Others are castaways, exiled by violence. In young solar systems, chaos is the rule. Massive planets jockey for position, gravitationally shoving each other into new orbits, gaining and even losing mass, as some theories now predict Jupiter might have been twice as large in the past, and migrated closer to the sun than far away again. One close pass too many, and a world can be flung outward with enough speed to escape its star entirely. This process, known as planetary ejection, may have played out in our own system. Some models suggest our early solar system once hosted additional planets, super-Earths or Neptunian-class worlds, now long gone. And again, we believe there's a good chance Jupiter migrated and disrupted the early solar system, and we've likely passed very close to other stars in the past too. Stellar encounters add to the drama. A passing star, brown dwarf, or even a rogue planet itself might drift close enough to destabilize a system, yanking a planet free. And while such flybys are rare in the modern era, over billions of years near misses accumulate. We believe Schultz's star passed under a light year from us as recently as 70,000 years ago, and that Gliese 710 may pass as close as 22 light days from us in just over 1 million years. The Milky Way is a crowded place, and planetary orbits are not eternal. Ejection can also result from binary star systems or from long-term gravitational tugs, like a cosmic tug-of-war between giant planets and moons. Needless to say, a world kicked into the abyss doesn't stop being a world, it just becomes a very lonely one. But lonely doesn't mean lifeless or useless. Life in the dark, rogue planet biospheres. At first glance, a rogue planet seems like the last place you'd expect to find life. Drifting through the interstellar void, it receives no starlight, no warmth from a sun, and little more than cosmic radiation and distant starlight to illuminate its skies. The surface might be hundreds of degrees below zero, with atmospheric gases like nitrogen and oxygen frozen into snow or ice. But dig a little deeper, literally, and things begin to warm up. The most likely candidate for life is the Steppenwolf planet, named for its lone wandering nature. The animal, not the band, though both fit. These are Earth-sized or larger worlds with thick ice shells trapping subsurface oceans heated by geothermal energy. On Earth, life thrives around hydrothermal vents deep beneath the ocean, entirely cut off from sunlight. It's even the lead candidate for where life first emerged. The same kind of ecosystem could develop on a rogue world, especially one with ample internal heat from radioactive decay, remnant core heat, or tidal forces from captured moons. Remember that even 4.5 billion years after formation, Earth's own core is still hotter than the surface of the sun. Going back to moons around rogue planets, many icy moons in our own solar system, like Europa and Enceladus, are already considered prime candidates for life thanks to these tidal force conditions. Some theorists have even proposed that such planets could host life adapted to very dim light, or even infrared radiation. If geothermal energy escapes through cracks in the ice, it could allow for bacterial life that feeds on heat gradients or chemical nutrients, a form of chemosynthesis rather than photosynthesis. And while biology might get stranger in the dark, it wouldn't be impossible. Life may adapt to survive in sub-freezing ammonia slush, or even swim in liquid hydrogen oceans at super cold temperatures, though these would be truly alien environments where familiar rules might not apply. Settling the shadows, habitats on rogue planets. When colonizing rogue planets, our first challenge is the lack of sunlight. No solar power, no day-night cycles, no heat from a parent star. But that doesn't mean no energy or no options. No light, no problem. We brought fusion and fortitude. A rogue planet's surface might be lethally cold, but just below that frozen crust, heat can still be found. And with modern technology, or the help of fusion reactors, we don't have to settle for mere survival in bunkers. We can build thriving settlements, whether beneath the ice or floating on alien seas. Buried cities beneath the ice. One of the most straightforward options is to dig in. On many rogue worlds, especially Steppenwolf-class planets, the upper layers may be frozen solid, but beneath that crust lies potential warmth, either from geothermal activity or the residual heat of formation. We might imagine vault cities, circular hubs entrenched kilometers deep, their walls lined with insulation and radiation shielding, their ceilings glowing with artificial sunlight powered by reactors humming in nearby cores. Vertical farms could grow algae, fungi, and engineered crops in stacked tiers, while waste heat from fusion plants keeps the local environment temperate. Fungi, not crops, might dominate early food production, especially in geothermal greenhouses where low light and high humidity are ideal for mushroom-based agriculture. Floating cities on cryogenic seas. And then there are the surface seas, oceans of liquid helium or hydrogen that might form under high pressure and the right atmospheric conditions. Imagine city ships designed like gargantuan Arctic oil platforms floating on a lake of liquid hydrogen at just 20 degrees above absolute zero. Their hulls would need to be made of materials that don't become brittle at those temperatures, likely layered metamaterials or exotic carbon composites. These cities might hover just above the liquid using magnetic repulsion, superconducting skates, or even self-repairing rafts that float due to the density differential with whatever cryofluid lies beneath. Mobility and expansion, connecting the cold frontier. Surface travel would be slow at first, likely reserved for robotic drones or sealed transports following preheated tunnels or rail corridors carved through the ice. Magnetic levitation trains, supercooled superconducting conduits, or good old-fashioned pressure-protected freight crawlers could move people and goods between outposts. Power would flow along these veins too. A well-planned colony network could transmit energy from major fusion plants to distant outposts via superconducting lines buried in the ice or rock. A rogue planet might be dead to the eye, but underground it could pulse with life. Vibrant civilizations or engineered ecosystems or even crazy cults or pirate bases hiding from the outside cosmos. And if these worlds are common, as current evidence suggests, then it's not hard to imagine a whole network of rogue worlds. Some might have multiple colonies, others might serve as fuel depots, military stations, or scientific archives. Over time, such worlds could even become the backbone of a slow interstellar expansion, what we call colonizing, should faster types of travel not become practical. Rather than leaping from star to star, humanity might march across the galaxy one rogue world at a time, not colonizing the light, but mastering the dark between it. Out of the darkness, a future in the void. Rogue planets are by their nature places of silence and solitude. There are no sunrises, only the soft glow of distant stars and the quiet hum of machines keeping life alive. But perhaps that's part of what makes them so compelling. And perhaps they're not the backwaters of interstellar civilization, but its backbone, rugged, self-sufficient, and strategically vital. The relay points of vast interstellar laser highways, pushing ships to near-light speed or slowing them down from it as they travel unrestrained by the tyranny of the rocket equation. The people who call such worlds home would grow up without ever seeing a blue sky except for those they build. Their legends might speak of stars the way we speak of mythical golden ages, and when they finally journey outward to find them, it won't be as wide-eyed explorers, but as hardened pioneers, heirs of the deep dark, bringing with them the knowledge of how to build light where there is none. Torchbearer fleets. And it's worth remembering, these planets are not just potential homes for us. They may already be home to someone or something else. If the galaxy harbors ancient intelligences or forgotten biospheres, simple biologies or massive post-biological entities calculating away in the cold hidden depths, it might not be the bright stars we should search, but the lonely shadows drifting between them. Rogue planets are reminders that the universe doesn't offer us a warm welcome, but that hasn't stopped us before. We'll bring our own fire, our own future, and write our legends even in the dark.